तो ये हेलो,
हाँ सर।
मैं स्टार्ट करता हूँ। ओके, सो
Yes, sir.
तो लास्ट क्लास में हम लोग मतलब लास्ट तो नहीं, दिस इज द जिस्ट ऑफ इंटरफेरेंस superposition of two waves. So we have seen that the intensity at P actually is a function of cos delta phi, and this delta phi is actually the initial phase difference and then path difference traveled by the two waves. There is two contribution. So this will give you. So this variation will come if you move over the screen. So this here actually your x2 minus x1 is 0. Here x2 minus x1 is greater than 0. Here x2 minus x1 is less than 0. So that means if you move over the pattern, you will see the variation of intensity, and that is we call interference pattern. Now this pattern you only can observe. प्लीज ये जो लोग ज्वाइन कर रहे हो प्लीज, ये बहुत दिक्कत होता है, हर बार मुझे आके ज्वाइन कराना पड़ता है, इट्स वेरी डिस्टर्बिंग. इफ यू डोंट वांट टू ज्वाइन प्लीज डोंट ज्वाइन. I will not, do not please, who are there, try to understand. It's very, very noisy and disturbing in the middle of something to join someone. हर बार मुझे कंप्यूटर के पास आना पड़ता है. क्या प्रॉब्लम है आप लोगों को? 5 मिनट में ज्वाइन नहीं कर सकते? Now what I'm trying to say that if you want, so if you move over the screen, you will see that x2 minus x1, that is actually path difference is changing, and due to this change, you can have a change in delta phi, and this delta phi brings change in intensity variation. So that means this is the interference pattern. So now if you want to see the pattern, you need to have this phi2 minus phi1 constant over a time. Otherwise, you will see a dynamic pattern and if I told you that if you have a dynamic pattern and then you have to take a time average, then you will see that it just gives you the continuous I0 plus I0. Okay, and it should be so what I'm trying to say, it should be constant to observe static interference pattern. Otherwise, you will see dynamic interference pattern. So now, to make this is constant, this was to make delta phi, phi1 minus phi2 constant. So you need to have phi1 equal to constant and phi2 equal to constant. These two, if they are not constant, then this will not be constant. So that means you need to have a coherent pair of sources, जो मैंने बताया था last class में. Otherwise, you won't get delta phi equal to constant. So one method is actually division of wavefront. मैंने बताया था. So now what I told in the last class that if you have two independent sources, so that means S1, S2, if they are independent, that means suppose if you have a double slit here, you put one candle light here and you put another candle light here. So these are the two independent sources. So if you use two independent sources, they cannot be coherent source, because there is a reason, because whatever the origin of the light emission of candle or any incandescent sources, they have some atomic origin and they have 10 to the power minus 8 second time gap between two pulses. Okay, so that means you will have a pulse trend which has always a time gap between 10 to the power minus 8. That means second means every 10 to the power minus 8 second you will get a new phase, initial phase, which is emitting from the light source. So we cannot have two. So these two pulse trend cannot be actually similar, and their difference will not be constant at all. So it's better to start with a single source and then divide it, split it up in two to get a pair of coherent sources. So one method is Young double slit experiment, as I told you. So let's do it. So this is one method. It's called division of wavefront. Division of wavefront. So there is another example of division. So here what we do, we physically divide the wavefront, okay, by placing slit, and we can use that arrangement to create a pair of coherent sources. Let us draw what is the experimental setup of Young double slit. So it is actually given by Thomas Young in 1802, okay, to observe the interference pattern very precisely. So what we have, so let's say we have a screen, suppose, and behind the screen, we have a source here. If you have a candle here, now if you put a hole here, so the whole, instead of using the whole candle as a source or whole light as a source, and this hole will act as a point source. Okay, so we need to have a point source, not the extended source. Suppose if I put a tube light here, so it will become a extended source. So its wavefront will not be spherical. But if I put a screen and then I put a hole here, very small hole, the light coming out from that hole, it will give you a nature of point source, and you will have a spherical wavefront in nature. So now you put another screen after that. The screen after that. So now, so let's say this is the line. Okay. So now just making this one is actually your middle point. One hole here and another hole here. Okay. So now we put another screen here. Okay. So this is the screen. Let's say this is the middle point. So it should touch somewhere here. Okay. So this is the screen. So this is slit 1. This is slit. Sorry, screen 1. So it will give you two slits. So slit 2 and this is screen. Okay. So now what we will do, let's say this is your y direction. This is your vertical direction. Let's say it is y, and this is actually your x direction, and this is your z direction. So that means actually what I'm trying to say, that suppose this is your flat board of the table for experiment. So this is your first screen, then you will have second screen, then third screen. In the first screen, we have one single hole, and behind this hole, you have a source here. So let's say we can say this is a source S, okay, original source. So now this source will emit. So since it is a point source, it will emit a spherical wavefront, and this spherical wavefront will propagate forward in this direction. Then at some point of time, it will strike the second slit. Here we have, it is just a opaque object with two holes. So that means the whole wavefront will only divide it into 2 points. Let's say it is S1 and S2. These are the two source. It will act as a two source because we know that, let's say these two distance is the distance between two slits is D. Okay, so now we place a screen at D distance between the slit and the screen. Okay, so now what will happen? So this single source wavefront, spherical wavefront, will be divided into two parts, S1 and S2, and these two wavefront will approach each other along the negative z direction, and they will meet in this area. Now, if I put a screen here in xy direction, then you will have an intersection with the interference pattern on the screen, and you will see the 2D pattern on the screen, interference pattern on the screen. This is the arrangement of Thomas Young double slit experiment. So now what is happening if I see here? So this is the screen. Okay, this is the screen. Now we have a light source here. Maybe it's a little bit extended light source. So now since we have a screen here and we have a hole here, very small hole. So that means this hole opening S will act as a source. Okay, and since it is a point source, so it will emit spherical wavefront. जो मैंने last class में पढ़ाया था, उधर class में पढ़ाया था. So now what will happen? This wavefront will propagate in this way, and then at some point of time, so this is the one single wavefront, let's say, which meet at here. So that means, let's say, it will strike with the screen. So only we have which have only two openings, S1 and S2. So that means if I put the screen here, okay, if I put the screen here, so most of the wavefront will be missing except these 2 points. So except these 2 points, most of because they will be obstructed by the screen. So you have S1 and S2 here, and since from the Huygens principle we know that each point on the wavefront will act as a secondary wave source, a light source, secondary wavelet, and it will emit the light with the original source. That means same as the original source, in sense that it will create similar wavefront like spherical wavefront, and similar frequency, omega will be same and initial phase will be same. Okay, let's say that means it will also emit spherical wavefront like that, and it will also create spherical wavefront like that. Now we have two sources, S1, S2, which creates spherical wavefront, and they can meet at the screen somewhere, and you can observe interference pattern here in the screen. So this is the arrangement of Young double slit experiment. So now what is happening? You have a one single source which is emanating spherical wavefront. Now we can divide the wavefront in two parts. So S1, S2, which also emanating spherical wavefront, and since they are actually derived from the same source S, so they must have a phase relationship between them. So now what I'm trying to say that, so let's say here in this source, the equation, let's say A cos omega t plus phi. Let's say this is the equation of the light coming out from the source S, okay, which is y equal to a cos omega t plus phi 1. So now here, so it will now divide, this will divide into two parts since the wavefront is dividing. So now what hygiene says that, so these two sources S1 S2 will bear the same signature of the original source. So that means this is for S1, maybe S source, okay. So now for S1 source you can write the equation, let's say y1, and intensity will be different, that is no issue in that. So cos omega t plus, now what will be the phase, initial phase of the light coming out from S1? Let's say it is actually traveling x1 path and this one is traveling, let's say, x2 path. Okay, so now, so what will be the initial phase of the light coming out from S1? So now we know that it was the initial phi was the initial phase of the original light, it will remain same, and some phase difference will add up. Phase will add up because of the traveling of the wavefront from here to here. So how much it's traveled? Let's say it is traveled by x1 path, so it will just add up like this. Similarly, for S2 source, y2 a2 cos omega t plus phi plus k x2. Okay. So now, so how, so to write this one we use only one fact that which is actually cleared by Huygens. He said that if you divide the wavefront, means each point on the wavefront, like S1, S2, these 2 points on the wavefront, this spherical wavefront will actually produce light which is similar to the original source S. Similar, why? How it is similar? It will have same angular frequency. It will have same initial phase. Okay. So now since it's travel x1 and x2 path, so that means some phase will add up because of the traveling of the light from original source to secondary source. So now what is the phase of this one? Let's say theta1 is the initial phase of y1 light coming out from S1, which is phi plus kx1, and let's say theta2 is the phi plus kx2. So now the phase difference between S1 and S2 source is now delta theta2 minus theta1 just k x2 minus x1. This is the initial phase difference between these two sources. So now since we know that this experimental setup is fixed for a particular experiment, so that means x1 and x2 will also be fixed. So that means it is constant over a time. Constant over a time. Okay, so that means this is the example of coherent source. If the phase difference is constant over a time, then we can say H1 and H2 are coherent sources. So now, so that is how actually in double slit experiment, Thomas Young produced a pair of coherent source by splitting the wavefront into two part H1 and H2. Okay, समझ में आ रहा है? Any question about it? Hello.
Yes sir.
कोई क्वेश्चन है? ठीक है अभी?
Yes sir. Clear.
सर θ1 θ2 की जगह φ1 φ2 भी ले सकते हैं?
It's your choice. मैंने फाइल लिखा था तो मैंने कहा था ठीक है, कोई प्रॉब्लम नहीं है। अब जो लिखेंगे उससे कोई मतलब नहीं है। 5 1 5 2, ठीक है।
ओके सर।
Now, so we can find out uh, theory of fringes. Okay, theory of fringes is a part of the Young double slit experiment where we will find out the how the fringe pattern in Young double slit experiment looks like. अभी तक तो हम लोग बता रहे थे कि इंटेंसिटी वेरिएशन होता है, ओके। सो वी डोंट नो व्हाट यू हाउ विल बी द पैटर्न, because only superposition will not only decide, the experimental setup will also decide what will be the nature of the fringe pattern. जैसे कभी कभी कुछ diffraction interference pattern looks like concentric circular circle, कभी कभी क्या बोलता है इक्विडिस्टेंट लाइन स्पेसिंग होता है, ठीक है। सो लेट्स सी व्हाट वी कैन से व्हाट वी कैन एक्सपेक्ट द अबाउट द फ्रिंज पैटर्न इन यंग डबल स्लिट एक्सपेरिमेंट। सो व्हाटएवर एक्सपेरिमेंट we have how to say, we have schematically explained in the earlier board, so we can make a simplified phase schematic diagram. So out of it, let's say this is the line. So we have, so this is the source. Let's say one source is here, S, जो कि single slit में है, okay, आप slit में डाले थे। The first slit will can represent by this one. So it is, so one wavefront is coming out like this. Now we have second slit is here. So let's say this is S1 and S2. Now this wavefront will split up and you will have separate wavefront from here. And now you put the screen here. So what was our direction? So it was actually along the Y direction and it was along the Z direction. X direction जो है, it is out of the plane. Okay. So now what I am trying to say that, so let's say we have a point. We have a point. The point. Let's say we have a point P, okay, which is actually a distance y from the central point O of the screen. Okay, this point O is situated in the same distance from S1 and S2. Okay, so this is your P. Now what happen? जो बार बार हम लोग ड्रॉ करते हैं, तो यहाँ से एक लाइट वेव जाएगा। ये मैं स्ट्रेट लाइन ड्रॉ कर रहा हूँ, बट इट इज ए वेव एक्चुअली, ओके। ओके, सो दीज आर, सो ये आपका S1 S2 है और ये दोनों यहाँ पे मीट कर रहे हैं। So now we know that this total distance is D, the distance between two slits. Let's say it is D, and the distance between the slit and the screen. So this is slit and screen. Let's say it is D. Okay. कौन मैसेज भेज रहा है? क्या सुनाई नहीं दे रहा है क्या? हेलो,
ऑडिबल
सर
सर।
आवाज
ऑडिबल
आ
है।
रही है सर।
सुनाई दे रहा है ना?
यस सर।
यस सर, यस सर।
Okay, okay, okay. So now we can say that. So now what we have to find out. Uh, so P is any arbitrary point. It's arbitrary point. Okay. At which we are interested. What will be the fringe pattern at P? ठीक है? So now what is the phase path difference? Path difference at P. That means if a light coming out from S1 will reach, it will travel a distance S1P, and the light coming out from S2 will travel a distance S2P. So path difference means x2 minus x1. So that means path difference at P will be S2P. Actually, the distance covered by the light coming out from the S2 source and S1P. This is the path difference. So now we know that this. So this is the path difference. Now, what will the phase difference? Phase difference. ये मैंने बताया था. एक फॉर्मूला है. Phase difference equal to 2 pi by lambda into path difference. Okay, तो ये हम लोग यूज करेंगे टू फाइंड आउट पाथ डिफरेंस. सो पाथ डिफरेंस क्या होगा अभी? फेज डिफरेंस. तो 2 पाई बाय लैम्डा इनटू S2P minus S1. Okay. So now we know that condition for, let's say, if we can have maximum is maximum intensity at P, then क्या होगा? फेज डिफरेंस will be multiply. मैक्सिमम का कंडीशन क्या है? डेल्टा phi will be 2n pi, where n equal to 0 plus minus 1 plus minus 2 like that. Okay, so that means, so your 2 pi by lambda into S2P minus S1P equal to कितना होगा? 2n pi. Okay, so now we can find out what is the value of S2P minus S1P. S2P minus S1P equal to क्या होगा? It will be just n into lambda. That means integral multiple of lambda, where n equal to 0 plus minus 1 plus minus 2 like that. Okay, so now we have to find out the relation between y and the path difference. Yeah. Okay, so now if I calculate S2P minus S1P, S2P whole square minus S1P whole square इक्वल टू कितना होगा? ये आपको क्या देगा? तो इट विल गिव यू. अच्छा बताइए, ये मैंने यहाँ पे परपेंडिकुलर ड्रॉप किया एक. ओके, और इधर भी एक परपेंडिकुलर ड्रॉप. ठीक है. अच्छा बताइए, S2P, सपोज दिस इज योर M, this is your N. So now if I take the triangle PS2N, then S2P actually it's a hypotenuse. So that means actually so E square plus E square. E square ये कितना है? So this is actually your D by 2. And this is also D by 2. तो ये कितना होगा? Pn square plus S2n square. That is actually S2P square. Okay? तो अगर हम उसको लिखेंगे, so it will become ये S2n square मतलब D square plus ये कितना है? So this is your y, this is y and this is d by 2. So that means if I say, let's say it is yn because we will explain why we are taking yn, y plus d by 2 का whole square plus similarly d square. तो अगर आप S1P निकालेंगे then you have to take the triangle PS1M. So in that case, this will become yn minus d by 2, and this is d square. Yn minus d by 2 whole square. Okay. So now we can move further. S2P minus S1P into S2P. ये कितना होगा राइट साइड? इट विल जस्ट बिकम 2yn d. राइट साइड अगर आप सॉल्व करेंगे, राइट साइड अगर सॉल्व करेंगे तो ये देगा. सो नाउ so S2P minus S1P equal to 2yn d divided by S2P plus S1P. Okay. So now, if I say that yn is very small, if yn is very small, what is the physical meaning of that? So that means if we are interested the fringe pattern produced nearby O. That means if the fringe is localized here, nearby the screen, not very far from the central point of the screen. That means if the fringe pattern is localized near O, that means central point of the screen. So that means in that case ये अगर P both आसपास हो जाएगा O के आसपास, that means S1P will become equal to S2P will become the D, the distance between the slit and the slit. It will give you S2P will nearly equal to S1P will be nearly equal to the D. So now we can put this assumption here. So it will become S2P minus S1P. ये अगर हम लोग यहाँ पे पुट करेंगे तो it will become D plus D 2y divided by 2D. It will be nearly equal to. So that means S2P minus S1P equal to yn d by d. So now, if I compare these two equations, we can write down. Compare this equation, we can write down. So S2P ये same है दोनों. So it will give you yn d by d equal to n lambda. So that means yn equal to ND by T into lambda. So that means, so from O point, okay, from O point, the central point of the screen, if you move y distance, you will get a maximum. Okay, so now why we put n equal to 1? Y instead of yn we put instead of y we put yn. So it is actually the position of the spring. It is the position of the bright fringe. हम लोग ब्राइट का कंडीशन लिए थे from O. Okay. So now ए आप लोग अभी क्यों ज्वाइन कर रहे हो? ये शुभम नारायण ना क्या नाम अभी ज्वाइन किया है? शुभम नारायण अभी क्यों ज्वाइन किया आपने?
सर सॉरी सर मैं थोड़ा लेट सर हो गया सर.
मैंने किस बात का लेट?
सर ट्रैवलिंग सर हम ट्रैवलिंग कर रहे थे सर. और सर मेरा सर नेट कनेक्शन भी सर ठीक नहीं सर चल रहा है सर. कभी कभी सर रुक जा रहा है, कभी कभी सर चल रहा है.
ठीक है, नो प्रॉब्लम. ये बहुत डिस्टर्बिंग होता है, मतलब क्लास के बीच में अभी हर बार मुझे जाके उसको ऐड करना पड़ता है. ओके ठीक है, जो भी है. सो दिस इज दैट मींस where n equal to 0 plus minus 1 plus minus 2 plus minus 3 like that. So that means, what is the meaning of that? This means, suppose if I take, this is the screen, okay, and this is the central point O, okay, so here that means it is actually n equal to 0. So n equal to 0, if I put here, yn will become 0. So this will give you the central bright fringe. Okay, so now if I put n equal to plus 1, suppose if I put n equal to plus 1, so then what will be the distance? This distance will become n equal to 1 hoga d lambda by d. So this is the distance of y1. So at d by d into lambda distance, you will get the first bright fringe. So this is the first order. The n is actually the order. So if n equal to 0, that will give you central fringe or zeroth order fringe. If n equal to 1, it will give you first order bright fringe. Similarly, if I put y2 equal to kitna hoga 2d lambda by d, so n equal to 2, it will give you second order bright fringe. Similarly, if I put n equal to minus 1, so that will also give you minus d lambda by d. So this is actually also first order bright fringe. Similarly, for n equal to minus 2, it will give you second order bright fringe. Okay, so now ये तो ब्राइट फ्रिंज हो गया, तो डार्क फ्रिंज कहां से आएगा, मिनिमम पैटर्न कहां से आएगा? So now what we can do, similarly we can put the condition for minimum intensity. I will do that later. So let us find out what is the width of the fringe. So that means if I plot this one, this plot, if I plot this one, how it will look like. So if I plot this one, suppose, so let's say this is your O position, this is the screen I am plotting again here. So now in center you will have a bright fringe here, okay? Okay, then in n equal to 1, you will have another bright fringe. Okay, फिर n equal to 2 we'll have another bright fringe. So this is n equal to 0, this is n equal to 1, this is n equal to 2. Similarly we will have n equal to -1, n equal to -2, something like that. Okay, so now what is the fringe width? Fringe width actually the this distance between two consecutive bright fringe will give you the thickness of the bright fringe. Okay, so now two consecutive bright fringe का distance क्या है? Fringe width. So this is your bright fringe width, because we don't know yet what is the dark fringe. Now
lambda by d.
yes, so I write. So now what is fringe width? Fringe width we can find out. So we know that y a equal to क्या था? n d lambda by d. This is your n, yl. Okay, मतलब is the position of nth bright fringe. Position of nth order bright fringe. Okay, so from where we are calculating? We are calculating from O point. Okay, the central point of the screen. कितना time हो गया? Okay, we have time. So now, what is the next position of the next bright fringe? Let's say n plus 1. So n plus 1 is d lambda by g. So this is the position of n plus 1 order bright fringe. Okay, so now fringe width. Let's say fringe width of what? Fringe width of nth order bright fringe. Nth order bright fringe. That means beta n will become yn plus 1 minus yn, which will give you simply d lambda by d. That means beta n is equal to d lambda by d. So now simply you can also find out beta n plus 1, which is actually, you can also similarly find out beta n plus 1 equals to yn plus 2 minus yn plus 1. That will also give you d lambda by d. So that means all fringes are equal width, have equal width. That means beta n equal to beta n plus 1, which means the bright fringes have equal width. Okay, तो यही है. So similarly we can also do the same thing with dark fringe. So we know what is dark fringe. आप लोग कर सकते हो उसे. ये ठीक है ना, कोई प्रॉब्लम? ये था पहले भी किए हैं आप लोगों ने क्लास 2 में, आई थिंक.
Sir, what is the order of central bright fringe?
Zeroth order, 0. n equal to 0 will give you the zeroth order. n का वैल्यू क्या है? n का वैल्यू
Okay,
है
sir.
0, 1, 2, 3, -1, -2, -3. So this is zeroth order, first order, second order, third order. First order, second order, third order, both sides of the screen. ठीक है? So now देखिए, similar calculation you can carry out for dark fringe also. Okay, तो dark fringe का कंडीशन आप ये करने की जरूरत नहीं है, because they are same. तो फिर भी मैं आपको बता देता हूँ कैसे करना है. You can do it in similar way. अच्छा बताइए. Now we have to say that let's say yp, let's पहले हम लोग क्या बताया था, p पॉइंट में हम लोग मैक्सिमा कंसीडर किए थे, है कि नहीं. Now let us consider at p we have dark fringe or minima. So that means S2P minus S1P ये आपका पाथ डिफरेंस है, ठीक है. इससे हम लोग 2 पाई बाय लैम्डा से मल्टीप्लाई करेंगे, so this will give you the phase difference, okay, and it will be equal to 2n plus 1 into pi. This is the condition for minima, odd multiple of pi, okay.
सर वहाँ पे 2n-1 भी हो सकता है.
हाँ ऑब्वियसली नो प्रॉब्लम. वन भी आपको कुछ सेम चाहिए. अगर इनफैक्ट इफ यू वांट टू हैव then for minus value you will get plus, plus value will get minus, same है. They are constant, no problem in that. So that means you can have S2P minus S1P equals to क्या होगा, n plus half into lambda, है कि नहीं. ये आपको मिला है. और एक हम लोगों ने प्रूव किया था S2P minus S1 फ्रॉम द जियोमेट्री. क्या आया था ये, वो नीचे था ना 2D, क्या था ये 2yn ऐसा था ना.
हाँ सर.
Now they are almost equal and they are individually equal to d, so that means it will give you yn d by d. So now if I compare these two stuff together, then you will get compare, क्या देगा ये yn d where n equal to 0 plus minus 1 plus minus 2 dot. Okay, now from here you can find out yn. yn equal to क्या होगा,
n+1/2 lambda small
d lambda by d. So yn is what? This is actually the position of nth dark fringe or dark or nth minima, nth order minima or nth order dark fringe. Okay, now same thing you can find out the fringe width of nth order dark fringe. क्या होगा, let's say this is beta n, okay, beta n dark में भी और लास्ट में बीटा n ब्राइट था. Okay, let's say it is बीटा n dark fringe. कितना होगा, y n plus 1 minus yn. That will also give you again d lambda by d. So that means compare two stuff, you will get beta n bright fringe equal to beta n. So that means the fringe width of dark and bright, they are same, equal. Okay, what we have more? Nota 25. Okay, what is the shape of the interference pattern? The shape of interference fringes of Young double slit. Okay. So I will not derive it. The shape is actually hyperbola. I will just find out. ये रिलेशन जो है, जैसे हमारा क्या था, ये स्क्रीन है आपका और ये मिडिल पॉइंट है, S1 S2 और ये P है. Now S2P minus S1P equal to delta. It is actually path difference. So now, which is constant? For constant P, for a particular point P, so S2P minus S1P is constant. अतः ये इक्वेशन हम लोग कुछ देखा देखा सा लग रहा है ना, जैसे अगर कोई पॉइंट का लोकस दोनों पॉइंट से ऑलवेज इक्विडिस्टेंट है, इसको क्या बोलते हैं, क्या लोकस देता है ये? आप लोग याद नहीं आ रहा है
सर? डार्क फ्रिंज के लिए yn+1 माइनस yn करके 2d लैम्डा बाई डी आएगा ना सर?
2d लैम्डा बाई आएगा. क्या आप कर रहे हैं? ये सेम आना चाहिए
सर 3/2 माइनस हाफ 2.
एक मिनट रुको, क्या था ये? yn इक्वल टू था n
प्लस हाफ d लैम्डा बाई डी.
ओके. yn प्लस 1 कितना होगा? क्या होगा ये? n प्लस 1
3/2
d लैम्डा बाई d. तो ये माइनस करेंगे तो क्या होगा? माइनस करेंगे 3/2 माइनस हाफ क्या होगा?
2 आएगा सर.
2 आएगा कैसे? 1.5 से हाफ
सेम होगा.
ओ सर मैं साउंड कर दिया.
सही होगा सर. 2 नहीं होगा सर, सही है.
सही है.
यस सर.
नहीं आपने 5 ले लिया उसका. अच्छा ठीक है, ये आप लोग यार ये मैंने उल्टा ड्रॉ किया तो पता नहीं चल रहा है. सपोज ये डायरेक्ट्रिक्स है और ये आपका स्क्रीन है, S1 है, ये S2 है. So now let's say we have a point here P. Okay, suppose this is a point somewhere. Okay, this is the screen. Okay, so this is the screen. Let's say this is XY screen है और ये आपका स्लिट है S1 S2. So now if I take a point P, so that means S1P minus S2P equal to constant. ये कंडीशन किसका कंडीशन है?
हाइपरबोला का.
तो इससे हाइपरबोला. So that means the fringe pattern of Young double slit experiment, they are not straight line actually. They are hyperbola in nature. Actually, in space it is a hyperaboloid, but when you place a screen XY, so it will cut the hyperbola 3D evolution and it will give you a 2D hyperbola. Okay, so in 3D it is hyperaboloid, but in screen when you put it, it will give you a high parabola. Okay. So that's all for Young double slit experiment. So now using Young double slit experiment, we can do one problem. It's called measuring the thickness of a very small slit. Hey, what is very small film? Okay, मैं ये काल काल तो नहीं करूंगा क्लास, मंडे को कर दूंगा. तो then your young double slit will be finished, and maybe then we'll start thin film interference. Okay, so that's all for today. See you Monday.
Thank you, sir.
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 Thank you.
Thank you, sir.
Thank you, sir.